So for today, I get to teach you about permutations and combinations. One of those words you've heard before, and one of them probably only a couple of you have heard before. Combination, you've heard of combination a million times, okay? Combination is like you order a pizza and you want a combination of cheese and pepperoni and sausage. That's a combination. Because you don't care what order they put it on the pizza. If you do, you probably have a problem. Because you call up the pizza place and you're like, I want it pepperoni and sausage and it has to be in that order. They're going to be like, what? What is wrong with this guy? The order doesn't matter sometimes. That is called a C, combination. Would you please put, let me see, 1, 2, 3, 4, 5, C2, for example. That is a combination question. This is generally NCR. That's the general format for it. If you were to look it up on your calculator, on the graphing calculators that you're going to use on the ACT and use every day in here, those graphing calculators, they call it NCR. C stands for combination. N is the number of things that you have. And R is how many of them you pick. I would have called it P if it was me, for P for pick, but they called it R. So this means there's like 5 people. I did that because I'm going to use this row. It's the easiest one to identify, the one against the window here, the window row. There's 5 people in that row. And if I'm going to pick 2 of them, and yay, you win. Did the order matter then? No, because they both win. So there's no order issue, so this is a combination. If what order mattered, it would be a permutation. Please put that down here, 5P2. So on this, order matters. I'm going to say something annoying, but it works for me. Order matters. The one that has a P, the order matters. So order matters. You remember it however you want to remember it, but that's how I remember it. The P kind is the order matters, order patters. Okay, so that would mean I got these 5 people, and I'm going to pick the class president and vice president. Does the order matter in that? Yeah, because clearly president's better, especially in like the U.S. elections. Vice president, it's almost like an embarrassing position in a way because they don't really do much. They're there in case the president dies, and there's a few other things they can do, but the president is like way more powerful. So the point is, if order mattered, like president and vice president, you'd use the P kind. If I'm just picking 2 kids and they both win, then the order doesn't matter, and this is called a combination. Combo, and this is a permutation. All right. Now I need to give you the little formula for figuring these out. Put that next to each of these. And to do this, I need a little background in the exclamation mark. There's a few of you that are going to know what I mean when I say 5 exclamation mark. Does anybody know the official name for it? It's not exclamation mark. Yes? You might know what it means, but you know the word first. Starts with an F if you're debating. What do you think?
What was it? Factorial?
Factorial, very good. That is called 5 factorial. And does anybody want to explain what it means? Yes?
So for 5 factorial,
Yup.
it would be 5 times 4 times 3 times 2 times 1.
You got it. So, for the C problem here, that's a combination where the order doesn't matter. It's 5 factorial over 5 minus 2, and you wouldn't have to write that. I'm just showing you how I got it. Factorial. So what is 5 minus 2? It's really 3 factorial. And what is 3 factorial? It's 3 times 2 times 1. So my answer to this question of there's 5 people in that row, and I can pick 2 of them to win. Then there's cancels, 20 different ways I could pick that. Like U and U is a logical comma in the front two spots, and the order doesn't matter. So that's one combination. I don't switch you around. I just one combination. Or I could pick the person in the front and the person in the back, and that's another combination. And then I keep doing that, and there's 20 combinations. How about permutations? They are similar, but different. Oh, wait, and I just messed up. I am so sorry. I did this in the other order in the other class. It's not completely wrong, but it's slightly wrong. Please erase the answer. All right, there's one more thing I forgot. On the C problem, there's an extra number on the bottom. There's an extra of that on the bottom. So I put an extra 2 factorial, whatever's here, the R number, I put an extra 2 factorial here. 2 times 1. So now it's 20 divided by 2, which is 10. Sorry about that. It's easy to forget that, and it might happen to you, so don't laugh at me too hard. That's combination. There was 10 combinations of kids that I could pick from that row. Okay, now what if the order matters? The order matters. It's a P problem. Then it's 5 factorial over, it's the same exact thing, except I don't have to forget that other number. There's no other number. It's just those two. So that's really 5 factorial over 3 factorial, which is really 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Cancels. Answer is 20. I was doing that before and forgot. Now, does it make sense that the one where the order matters would have more answers? Yeah, because like if I pick these two kids in the front and it matters whether you're first or you're first, then there's twice as many answers. See what I mean? But be careful. It's not just always twice as big, because if there's 3 people being picked and the order matters, then it's not just going to be double. It's going to actually be like 6 times as many or 3 times as many answers. So these are always bigger though, because the order matters, and so switching them around at least doubles your answers. Okay, there. That was pretty intense. And I have one more thing I need to show you, and then theoretically, we've done everything. I need to reinforce it, but the last thing here is that I can do this problem completely differently if I want to. Let me show you why. Because on the second problem, where the order mattered, on this kind, I could think of it as choices. Remember, I had 5 people and I was picking out 2 of them? How many spots are there? There's 2 spots. How many people do I have to pick from? I could pick 5 different people for that spot. And then if I do pick a person for that spot, now there's only 4 people left. 5 times 4 is 20, and that's way easier, isn't it? So sometimes that blank method works pretty well. It's choices. Let me give you an example with license plates. Do you get that in Minnesota, there are letters and numbers on the plate? Did you know that? I'll give you an example. In the old days, when I was in high school, my driver's license was the Fez 470. It was just kind of fun because I remembered that number. FEZ 470. That was my license plate. I remembered it just because it kind of sounded funny. All right. There was 3 letters and 3 numbers. Now, since then, Minnesota has actually switched it around, and I believe the numbers are first now, but I could be wrong. Does anybody have their license plate memorized? You don't have to tell me your license plate, but are the numbers first or are the letters first? Letters are first. Okay, well, maybe it's still the same. Cool. All right. I know in some states it's like they've gone to having another letter here You know why you would do that? Because there's more choices then. Do you get there's 26 letters you could pick for this spot? And if it was a number, there'd only be 10. All right. So let me show you this question about how many license plates are possible then? Well, they do remove a few. Do you get if you have the FUC license plate? That would be unfortunate. They actually remove those. So nobody's got that license plate. Or the SEX, they remove those. Nobody wants to drive around the car and be forced to have like a dirty word, or not that that's a dirty word, but there are dirty words that are 3 letters long, and they take them all out. Okay, but assuming you don't have any rules like that, then if it's 3 letters and 3 numbers, then you'd have this combo. How many choices do I have for the first letter on my license plate? 26 letters. How many choices for the next letter? Well, it depends if you're going to let them repeat. And they do in Minnesota. You can repeat. So then there's still 26 choices, and there's still 26 choices. What if you're in a state that's much smaller? Like South Dakota. Very few people live in South or North Dakota. They might say, just to keep life a little simpler, that they don't want any of the letters to repeat. If they don't want them to repeat, then you'd have less choices. Because if you picked like an L for your first letter, you still can pick 25 things, but you can't repeat that. And if you can't repeat that one, now you only have 24 choices. Do you see what I mean about the repeating thing? If you can't repeat things, your number of choices keeps going down. All right. So, what if, I drove past this the other day, what if they have a W first? Why would they force you to have a W at the beginning of your license plate? Oh, you know about that one. So you. Yes. That person has had too many DWIs. And they actually get publicly shamed by having a license plate that starts with W. Now, some of you are going to go home and go, holy crap, my family has a W on the beginning of one of the plates. I didn't know what that meant. Okay, that's what it means if it starts with W. I know a lot of people are going to go home and check their license plates now. So if you have a W in the front, that means that they've had some issue with DWI. Otherwise, it won't start with W. So anyway, I really hope, I know that they start with W, but maybe there's some other thing that you can have a W and not have a DWI issue. Maybe that's possible.
That would suck.
I know. Then like there's some weird thing that's like, well, in certain cases you can have a W. But most people have heard of, I shouldn't say it that way. Many people have heard of the whiskey plate. That's what some people call the W plate, is the whiskey plate. Anyway, so if it starts with W, if you're forced to have a W there, then how many choices do they have for that spot? If it has to be W, 1 choice. See what I mean? Then you could have all the other numbers and letters could be, actually I saw one the other day and it was all numbers after the W. It was like W1472 or whatever. So I literally drove past one yesterday. I thought it was ironic because I was teaching this. All right, so anyway, if it's all numbers after that, then you'd have 10 choices, 10 choices, 10 choices, 10 choices, 10 choices. If it's all numbers after that on the whiskey plate. It was on the person I saw. There was only 1 choice for the first thing because it has to be a W, and then it was all 10 choices each. All right, so let's see if you get the blanks method, because that's really important. So imagine you teach a little kid's t-ball team, and you're the like coach for it, and there's 5 spots because there's only 5 kids on your team, but you got to pick the batting order, and it's kind of a big deal, like who gets the bat first and second and third. And if you're good at baseball, you start realizing that batting order actually really matters. They care a lot about who they put first. if you're a baseball player, you'd probably know that they want somebody who's has a high probability of getting on base. They want them here. So let's say that you have that person who's really good at getting a hit. Not necessarily a home run, but really good at getting a hit. And you know his name is Bob. And you really want Bob to be first then. So, how many choices do you have for that first spot? No. You want Bob there. One. Now, let's say that Jimmy, his mom talks to you, the coach, and says, oh, I'm going to be late to the game. Can you please put Jimmy last? And you don't really care that much, so you're like, sure, I'll put Jimmy last. So then I only have one choice for that spot. Because that way maybe his mom would be there in time to see him hit. Okay, and then last, the other spots. How many kids do I have left? 3 times, can I repeat a kid? No. 2, 1. I know this feels weird, but it's true. I only have one choice for first, and that's Bob, because he's awesome and he always gets a hit. I only have one choice for last, and that's Jimmy, because his mom wants him to be last so that she might be able to see him hit. And then these I can put anybody I want. So 3 choices, 2 choices, 1 choice. See how the choices thing could work? All right, let me do that same scenario in this room. There's 6 kids in this row, the middle row. Okay, there's 6 kids in that row. If I was going to create a batting order for you 6, but I don't know who's the best and I don't know anything else, I'm just going to create 1, 2, 3, 4, 5, 6. Then do you get, how many choices do I have for this? 6. And a lot of kids are going to think it's this. Why is that not possible? You can't repeat the same kid over and over again. After that first 6, I don't have 6 choices anymore because somebody was first. So now I got 5 and then 4 and then 3 and then 2 and then 1. Could that have been done with a permutation? Yes. It would have been 6P6 because everybody gets to bat. If you pick a different sport like basketball, in basketball only 5 people can be playing out there. So you might have 12 on the team, but only 5 kids get to go out there at a time anyway. And so then if it was 12 kids on the team, and the order doesn't matter in basketball. I mean, there's different positions, but like, I'm just going to pick 5 kids to go out there. That's 12C5. You catching on to this? All right. So let's do these 2 with formulas. 6P6, that's 6 factorial, over 6 minus 6 is 0 factorial. And I know that's going to seem like it's 0, but do you get that that would crash and there would be no possible answer? But in the real world, there actually is an answer to this question. So this is defined as equal to 1. So if you ever have 0 factorial, don't freak out. It's just equal to 1. 1 factorial is also 1, which is weird, but it's true. So then this means 6 times 5 times 4 times 3 times 2 times 1. And yeah, that means you could have done it with blanks if you wanted to. So blanks is a great tool, and you're going to use it on about half of the problems today. Sometimes the blanks work, sometimes they don't. So you got to know this way too. All right, 12C5. I hope you know it starts with 12 factorial. And then what always comes next is 12 minus 5 is 7 factorial. See how I got that? And it was just 12 minus 5. And on the C problems, you saw me forget this earlier. Do you remember there's an extra, what in this case? 5 factorial. Now this would be a pain in the butt. To actually have to multiply out 12 times 11 times 10 times 9 times 11. So what I would do is cancel a bunch of stuff. Let me show you. You don't have to write this out every time. But I'll show you how it'll cancel really nice. Over 7 times 6 times 5. You see where I'm going with this? There's a bunch that's going to cancel. And then the 5 factorial is 5, 4, 3, 2, 1. Now, this cancels with that. And then, let me see what else could cancel. Ooh, I can take this 5 and this 2, and that makes a 10, and cancel it with that 10. You can do that? Yes. It's a 10 on the bottom and a 10 on the top. And this is a 12. The 4 and the 3, that makes a 12. That cancels the 12. Cool. And now I'm left with 11 times 9 times 8, and that's my answer. Now, could you have done it on a calculator? Yup. On the test, you'll have a calculator. It's good. But you have to show work. And this would be how you'd show the work. And then at the end, you could use a calculator to just grind out the decimal answer. It's going to be 11 times 9 times 8. All right. So, I'm not naive enough to think that you're all ready for a test on this. You're not. But at least you've been introduced to it. You now know about permutations and combinations, how to do the little formula, and you all learned about how to do the blanks. And the blanks was choices that you multiply together. If I say, have you ever made people stand up for a picture? And it looks goofy if the person that's super tall, let's say you have two people that are super tall. It would look goofy if one of them's here and one of them's here. It'd probably be better to put them on the ends. Like if I have two tall people, let's put them on the ends, and the shorter people can be in the middle. Well, then how do you do that with choices? If I had two choices of tall people, then I would put them two choices here, but I've used up one of my tall people. One choice for that one. Then there were 4 people, and I've used up 2 of them. Then there's 2 choices left for this one and 1 choice left for that one. Think about it as choices, and then they're not that hard. All right, let's start the homework together. We're going to skip problems 3 and 4, which is a lot. So please find it. We're going to do problems 1 and 2, and there's multiple choices, or there's multiple parts, but let's start it together so you can get a feeling for how they go. Number 1. Peters, you got it? Did you read it?
An 8-volume set of reference books, the books are used frequently to back in random order. How many ways can the 8 books be arranged on the shelf?
I'm going to do this with blanks, but I could have done it with a P or a C. But the problem is, tons of kids think that if I have 8 books on the shelf, that the order doesn't matter. The point of the 8 books on the shelf thing is different ways you can arrange it, so the order does matter. So it's actually a P problem. So I'll show you how you could do it either way. There is 8 books. P means the order matters, because if you're arranging them, then the order matters. And I want all 8 of them on the shelf. I could do it that way. Or I could think of it as, I got 8 choices for my first book. Could that same book also be in this spot here? No, so then there's 7 choices for that, and 6 and 5 and 4 and 3 and 2 and 1, and you always multiply your choices. So there, they're going to come out to the exact same thing, whatever that really big number is. All right, now I'm going to just go off the script for just a second and show you something that's going to blow your mind. How many of you have ridden a bus to school at some point in your life? All right, next, how many of you remember that there's a little thing on right by the door that says max capacity? Let's say it's like 55. That's a typical one. There's 55 people that are riding that bus, and you want to put all of them on the bus. So let's say you rode up in a bus that was completely packed, 55 kids on it. You drive up to the school parking lot, and everybody gets out. Now, if everybody got back on, do you get the probability would not be high that you would end up in the exact same seats? Unless they told you, like, everybody, you got to sit in the same seat. Okay, otherwise, you get in a different seat, right? Let's say you just got off the bus and rearranged yourself in all the possible orders. Okay, so you kept getting off the bus, rearrange it, get off the bus, rearrange it, get off the bus, rearrange it. How long do you think it would be before you got every possible order?
A very, very long time.
Mm-hmm. Think you could do it in 2 weeks without ever sleeping? Not even close. In fact, if you started right now and you did it for the rest of your natural life, you would not be done, ever. It would take longer than 100 years. I know that seems insane. I know you don't think I'm possibly right on that. But if you do the math, if you actually do this, it's 55 times 54 times 53 times 52 times 51 times 50 times 49 times 48 times 40. Do you get how big of a number that would be? And then you got to figure it's going to take you at least 30 seconds to everybody off the bus and everybody back on the bus, at least 30 seconds. And if you just use those two numbers, and you say 30 seconds each, and you multiply it by 55 times 54 times 50 times 52, it'll be more than the rest of your life. Isn't that crazy? It's true. All right, so that's an example of an order. The order mattered, right? Otherwise, if the order didn't matter, everybody gets back on the bus, you're done. There's only one way, you're done. But if the order matters, it's 55 times 54 times 53 times 52. Okay, good enough. Let's do number 1, part B. Nikita, could you read me 1B?
How many ways can the books be arranged so that volume 5 will be the right book?
This one I have to use blanks. Anytime they force it to be weird, like, oh, by the way, this is some rule about it, you got to use the blanks. Now, a lot of people make this mistake, and I get it. They put this last spot, and they say, so 5 goes there. No. 5 does go there, but this is about how many choices you have. Do you have 5 choices for that spot? No, they said volume 5 has to go there. How many choices do you have? 1 choice. Now, there was 8 books, and we've used one of them up. So how many choices for this spot? 7 times 6 times 5 times 4 times 3 times 2 times 1. And yeah, there's going to be a 1 and a 1 in 2 spots, and that's okay. And you multiply that out and you get the answer, and that's the answer. All right. So see how sometimes you can use those little formulas and sometimes you can use the blanks? All right. I really hope that you come up and ask me questions. And today's assignment is not due tomorrow. It's just something we're going to work on today. And that's all I got for you for today.